All right, it's lesson 1.6. Sorry, had to sanity check. I've been recording lots of videos today for lots of different classes. 1.6 of pre-calculus function operations and composition of functions, aka function notation part 2. This may or may not be a review. It theoretically should be, however, should and did are two different things, of course. But we'll take a look at what we're gonna do. We're gonna kind of hit some definitional, really less definitions and more notation things, and then we're gonna jump straight in with examples of what's going on. So we're gonna kind of function notation, right? So we're talking about f of x. Yes, that's probably an f. Let me increase the size of my brush ever so slightly, and that'll help my writings over here. So we're talking about stuff like that, right? F of x. Now, f is a function of x in this quantity. It could be g of z, whatever. G would be a function of z. It can be whatever. We've talked about this before in our review section, and you've probably seen it before then, probably, maybe. Who knows? We'll see. It doesn't matter. We're going to be fine. All right, so one of the reasons why we start using f of x as opposed to just using like y, for example, right? One of the reasons we've said before is because it's more descriptive. It tells us what the dependent variable is, which is f of x, that whole thing. It also tells us what the independent variable is, which is the x. And so it's more descriptive. It also lets us add even more information and more usefulness. So if we have two functions, all of these are going to be, if we have two functions, f of x and g of x, they could be whatever. They could be defined as however, whatever, right? So if we have two functions like that, then we have some shorthand notation. So this is some shorthand notation that we can use. So the first one is f plus g of x. That is shorthand notation for f of x plus g of x, right? So that would be taking and adding the entire f of x function plus the entire g of x function, adding those together, right? So this is shorthand notation for that. You might also believe and understand and think that f minus g of x, that is the same as f of x minus g of x. This is obvious. I think you can see probably the pattern of where we're going to go for the next couple of things. If we want to do f times g, we do f times g of x. Now, it is really important because we're going to look at something that may be new. It shouldn't theoretically be, but it may be new, where instead of a dot, this turns into a circle, and that means something else, and it doesn't just mean fog. And so make sure your dot is a times dot and not an open circle, okay? But that means f of x times g of x. Makes sense. Last one is f divided by g of x is a shorthand way to write f of x divided by g of x. Okay, so all of these over here are kind of the shorthand way of writing these. Now, this kind of stuff we've kind of practiced before, but we're gonna get a little bit more practice with it here. Let's do some examples. I'm gonna shrink down my brush a tiny bit and do some examples. This will be example number 1. Actually, before I write example number 1, let me give some functions that we're going to use for the first few examples. So for these first 4 examples, f of x, excuse me, f of x equals x squared plus 4x, and g of x equals the square root of 3x minus 5. And so example 1, using these two functions, we want to find, for all of these, we want to find blank, so whatever's listed here, and list the domain of the new composite function. Okay, so we're going to first of all find f plus g of x. I think you can probably see where this is headed. So f plus g of x would be f of x, which is this one. And I'm going to go ahead and label these. I'm going to kind of put these in kind of sideways brackets just to kind of for notes purposes, at least on these first few examples. So this right here is going to be all of f of x, right? And so that is x squared plus 4x. And then we're going to add g of x. So that's going to be this whole other bit. So this is going to be g of x. Right? And so we're going to add the square root of 3x minus 5. So now we need to clean that up as much as is possible. So this would equal x squared plus 4x plus the square root of 3x minus 5. We can't simplify that any further because these two are not like terms, and that one sure is not like terms. So all we have to do is write the domain of this thing. So the domain for this one would be, let's write our domains in interval notation on these. I think that's a good plan. So we kind of look at this and remember when we're looking at domain, we want to think what x can be. And a lot of times this is a great example of that. We can think about what x cannot be, right? And so what cannot x be? Well, we can put anything in for these x's, but for this one, this inside bit has got to be greater than 0 because it cannot be greater than or equal to 0, right? So let's do a quick little jaunt over here and say 3x minus 5 has got to be greater than or equal to 0. If we add 5 to both sides, we end up with 3x is greater than or equal to 5, divide by 3. X has got to be greater than or equal to 5/3. So the domain is 5/3 to infinity and beyond. So there's the answers for the first one. Right? And then let's do another example using these same two things. Let's do example 2. We'll find f divided by g of x. So the same idea applies here. We're gonna make us a fraction, right? And we're gonna put f of x on the top of it. So we're gonna put x squared plus 4x on the top. And then in the denominator on the bottom of that fraction, we're going to put 3x minus 5. Square root of 3x minus 5. Right? Now, for the domain bit, what can x not be? Well, it's really similar this time, except it can't be equal to 0 either, so it's just going to be x is greater than 5/3, which in interval notation is... Oh, I wrote that one wrong. I made a mistake. It dawns on me that I made a mistake here, didn't I? This should have been that, but this one is not equal to. That is actually correct this time. My infinities are going nutso. So there you go. Let us look at the next thing, and that is is actual composition of function, taking one function and shoving it inside of another function, right? Which is not that hard. It's maybe a little bit confusing, but if we just take it one bit at a time, I think we can do this. Okay, so we're going to learn kind of another notation, a shorthand notation, and that is we read this f of g of x. Not fog, but f of g of x. I'm actually going to write that. The other ones were obvious enough that I just let it stand on its own. But we read this right here as f of g of x. Of x. So that's how that's read out loud. And what this means is we take and we put g of x, so that whole function, inside of f of x. So we take g of x and stick it in for the f of x, right? So that's what we're doing here. Now let's look at an example using that notation and doing that. We can do it. It's going to be okay. You got this. I have faith in your abilities. So we're going to use the functions f of x equals x squared plus 1 and g of x equals x minus 4. So for example 3, we're going to find f of, oops, mixing my notations all of a sudden for some reason, f of g of x. Okay, so this is what we're going to do. We're going to put the second one listed inside the first one. So this guy into that guy. So f of x, we're going to list everywhere there's a variable, which is one spot right there. We're going to put parentheses. Now, it's important to note that we need parentheses that are spread out enough that we can stick this whole thing in there. Now, on this particular example, an easy place to make a mistake would be to forget to put that squared in there. So don't forget that that's there. So then inside of this, which is f, this is going to be f of g of x still. We're going to take and put g of x. So this whole g of x, we're going to shove in there, x minus 4. Now we need to simplify this one. And so, depending on what your purpose is, this could be quite simplified, but we're gonna FOIL this out. So I'm gonna scratch paper this over here. X minus 4 times x minus 4. You could, of course, use a FOIL shortcut, but we're going to walk it all the way out in this particular video. First, x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And then finally, negative 4 times negative 4 is positive 16. We combine those like terms, and we end up with x squared minus 8x plus 16. Now, jumping back over to our problem at hand, that's this thing taken care of, right? So this would turn into x squared minus 8x plus 16. Don't forget to bring down the plus 1. And then we've got a couple of like terms in there. And we can combine this into f of g of x equals x squared minus 8x plus 17, right? So there's the answer to that one. Now we're going to stay on this same function, and we're going to also find g of f of x. So we're going to do it the other way around because the order, of course, matters. So for example, number 4, we're going to now find g of f of x. So this time, we're going to take and we're going to start with g and put parentheses where its variable is big enough to shove all this inside, right? And then we're going to stick f, all of f, inside of there. So we're going to replace that with x squared plus 1. Now we got to simplify this down. Now there's nothing squared here, nothing multiplied, so those parentheses are not really doing anything. So on here, we're just going to combine like terms. And this ends up becoming x squared minus 3. And that is, of course, g of f of x. Now we're gonna do one more. We're gonna do one more example, because you can have situations where you find a composition, but you have to restrict the domain in order for it to work. And so let's do one of those. This will be the last example. Example 5. This one, we want to find f excuse me, f of g of x for f of x equaling 1 over x plus 1 and g of x is x squared minus 9. So we do the same plan. We're going to put g into f. So we're going to write f with parentheses where its variable is, right? So we're going to do for f of g of x, I'm going to rewrite this down here, of g of x, that equals 1 over, and then big parentheses, big enough for that whole thing to shove in there. And then we copy everything else down, right? And then we substitute x squared minus 9, because that is g of x, into there. This turns into x squared minus 9. Let's simplify. Same sort of idea here. These like terms combine. And so f of g of x equal, what am I writing? Of x is 1 over x squared minus 8. Now, we could circle that, but we wouldn't quite have the whole answer. But because in order to do this, we need to limit what people can put in for x, right? Because x can't be just anything, because this has a restricted domain. Because we've got a rational function here. We've got x in the denominator. So this whole bottom bit has to be greater than 0. No, not greater than 0. It can't be 0. My brain was thinking about 3 different things at once. It can't be 0. So we need to figure out what the domain would limit to. So let's do a little side bit over here, and let's say x squared minus 8 equals 0. We need to solve for x. You could factor this. We're going to do it the other way, because we want to continue to get practice with this. We're going to isolate this x squared first by adding 8 to both sides. Right? So then x squared equals 8. How do we get rid of a squared? We have to square root it. Now, when we square root both sides of an equation, what do we get? We get plus or minus. So this x ends up equaling plus or minus the square root of 8. Now, this is pre-cal, and that square root of 8 can be reduced. So we need to do that before we finish up. So the square root of 8 has got a perfect square in it. It's got 4 in it. So we can split this into the square root of 4 times the square root of 2, right? What is the square root of 4? It's 2. So this turns into plus or minus 2 times the square root of 2. Now, So to write our final answer, I'm going to come back over here. It's f of g of x with these functions is 1 over x squared minus 8 for x cannot equal plus or minus 2 times the square root of 2. So that whole schmagoigle is the answer. And I believe, let me check my notes. Yep, that is where we are. That's it for this lesson. This is the shorter one. We've had some longer ones here recently, but this is a normal 20-minute lesson. We will see you in the next one. Bye-bye.